There are certain algorithmic tools which are fundamental because they can be applied to a wide variety of different problems. The first one that we're going to look at is the greedy method. So we're going to talk about the general design paradigm that is the greedy method technique first, and then in order to better understand it, we'll see it applied to a few example problems. In fact, you're going to see the greedy method come up in later chapters as well when we start talking about graphs. But the point of this chapter is to understand how the greedy method works as a fundamental design technique because it can be applied to even more problems than just what we're gonna see today. So the greedy method is often applied to optimization problems where we want to minimize or maximize some objective function. And the main idea is that we begin at some starting configuration, and then we iteratively make the best decision that we can at the time. So we make what's called a greedy choice. This is a locally optimal choice, and hope that it will lead to a globally optimal solution. But hope is the key word here because it won't work in all situations. It's not going to guarantee that we're going to come up with an optimal solution in all situations. But if our problem has the greedy choice property, meaning that there is a globally optimal solution that we can obtain by making those locally optimal improvements from some starting configuration, then our greedy method will work. If we start at some starting configuration and we repeatedly make these locally optimal decisions, and then we can guarantee we reach a globally optimal solution. This is only if our problem has the greedy choice property. So in general, we'll see that designing a greedy method, an algorithm which uses the greedy method technique is usually easier. We have some element of, we have some type of iteration where we start at some configuration, we just have to define what our greedy choice is, and then we repeatedly make that greedy choice. But the difficulty with a greedy method is in showing that our algorithm actually works, that it actually produces an optimal result. And in order to do that, in order to prove the correctness of our algorithm, we have to show that our greedy choice, that our problem has the greedy choice property. Before we get into a concrete example of this, I want to talk about how you could also view this. One way to visualize the greedy method is by imagining that you're trying to reach a tall hill, the tallest hill. So let's say this is you, and you're on some terrain here of hills and valleys, and your task is to find the largest hill, the tallest hill, which is here. But it's kind of foggy out, so you can only see maybe 10 feet in either direction. So a greedy approach to this would be you have two choices, either you go left or you go right, and which way you can go, you can define a greedy choice as just going to the next tallest point that you can reach from your starting point. So you compare 10 feet to the left to 10 feet to the right, and if you want to reach the tallest hill, then we'll move to the right because this is a little bit taller than if we were to go to the left. Then we start at this point and we make our greedy choice again. We could choose, once we're here, to go to the left or to the right, but we can compare between those positions which would lead us to a taller point. So that's our greedy choice. We're always at our at wherever we're at in our terrain, we can choose to go left or right, and we choose to go to that place which maximizes the altitude of our location, since we want to find the tallest hill, the tallest point in this terrain. So our greedy approach would kind of iteratively go to the right, to the right, to the right, until eventually we did reach this point exactly, which is that tallest hill. And this is our a local optimum. If we go to the left, this is decreasing, or the right, this is also decreasing. And this is also a global optimum. So in this case, we would succeed in, our greedy approach would succeed in finding that highest point in our terrain. But again, the greedy method isn't guaranteed to work unless our problem has the greedy choice property, meaning there is a global optimum that we can find by starting at some starting configuration and repeatedly making those greedy choices. And we can't guarantee that that'll happen all the time. So for example, at least not in this visualization. So for example, let's say we had this terrain. It looks kind of the same so far, and we have the same task. We want to find the tallest point, but we can only see in 10 feet in either direction because of the fog. And let's make our terrain a little bit different now and say we've got this huge hill. Oops, this huge hill over here. If we were to follow a griddy approach again here, we would again go to the right, always going to that place which will get us a little bit to a taller spot in our hill until we found this point. But this isn't a global optimum. It's a local one. If we go to the left or the right, we end up decreasing altitude. But really the global optimum was this hill over here that we never went to, we never saw, because we never went to the left. So this would be one example in which the griddy approach would fail. So in this case, this doesn't have the griddy choice property because we have a global optimal solution which isn't a local optimal solution. So this just gives a kind of a general idea of how the griddy method works. So let's see it applied to one problem that you've probably seen before, which is making change. So if you've ever made change before, then you've probably used a griddy method just kind of intuitively without really thinking about it. So the idea here is that we have some dollar amount that we have to reach, and we have a collection of coins we can use, like pennies, dimes, nickels, etc. But in order to reach this dollar amount, we want to minimize how many coins we return. So if we had, let's say, $1.10 that we had to return, rather than returning 110 pennies, we would return a dollar bill and then a dime. So something which minimizes the number of coins that we get back. So a griddy approach to this would be that we always return the largest coin that we possibly can. So for example, let's say we had coins which are valued at 32 cents, 8 cents, and 1 cent. And now let's say we want to return $1.10. So maybe this is that we bought something at the store, we gave the cashier a $20 bill, and then we're owed $1.10 back. How do we get that dollar amount back? We only have these coins to work with. We have to return $1.10, so we're going to choose, of those coins that we can pick from, pick whichever one is the largest coin amount, which in this case is 32 cents, and return as much of that as we can. So once we return a 32-cent coin, we're left with 78 cents left that we have to give back. So we're going to take another 32-cent coin, because this is the largest one we can pick from, and now we've got 46 cents to return. And we can still fit a 32-cent coin in there. Again, our greedy method here is to just always pick whatever the largest coin that will fit into the remaining amount that we have to give back. And we're left with 14 cents. So now a 32-cent coin won't fit into this anymore. So the next largest value we have to pick is the 8-cent coin. So using the 8-cent coin, so far we've returned 3 of the 32-cent coins and 1 8-cent coin, and we're left with 6 cents we have to return still. This is too small, an 8-cent coin won't fit into it, so now we're left with the 1-cent coins. So then we can return 6 of the 1-cent coins, and this is the minimum number of coins that we could return that would fit into $1.10. So this does have the greedy choice property because there's no amount over 32 cents that can be made with a minimum number of coins without using a 32-cent coin, and we can say the same thing for any value in between 8 cents and 32 cents. But this isn't true for any kind of currency. If we had, let's say, coins valued at 30 cents, 20 cents, 5 cents, and 1 cent, this one doesn't have the greedy choice property. And you can see that because of just one counterexample. If we had to return 40 cents, the best thing that we could do is pick only 2 of the 20-cent coins, but a greedy solution would pick the largest coin we could fit into that, which would be, so we've got 40 cents to return, it would pick a 30-cent coin, and then we've got 10 cents left. We don't have a 10-cent coin, so we would have 2 5-cent coins that we would return. So a greedy approach here would end up using 3 coins, but an optimal solution uses only 2 coins. Okay, we'll go through another example in the next video.